So this video will be on angle relationships, and a lot of the angle relationships might be a review for you. Some of them, maybe all of them, but we're going to throw in a twist at the end, which is how we bring it up to standard for high school geometry. So some of these angle relationships and names of angles you have experienced in middle school. So first we have our types of angles. And the first one we're going to talk about is a right angle. Now you want to just draw a table, 3 columns, and we'll go through all the types of angles. So a right angle is an angle that measures 90 degrees. And then we have a picture. Remember that we put this box in the angle, and that's what's going to signify that it measures 90 degrees. Next we have an acute angle. And an acute angle is an angle that measures less than 90 degrees. Now you might have ways to remember acute, like cute, tiny babies. That means less than 90 degrees. Whatever trick you use, just remember. And then for acute, I've shown that here's our 90-degree mark, and it's less than 90 degrees. Next we have obtuse angle. Now obtuse angle measures more than 90 degrees but less than 180. And so we have another angle that is when it goes over 180 degrees. So obtuse is just between 90 and 180. And then we've shown here with our 90-degree mark that obtuse is greater than 90. And then we have a straight angle. You might be able to guess what a straight angle looks like. It's just a straight line. A straight angle is 180 degrees, and it's a straight line. And then finally we have a reflex angle, and the reflex angle measures more than 180 but less than 360. And so we have our 180 mark, and this goes past 180. So make sure you have all the diagrams and definitions written down before you move on to the next part. So if you pause the video if you need to. But next we have our angle relationship. So I just talked about types of angles in the last table, and then this table will talk about specific relationships that 2 or more angles will have. So again, you're going to make a 3-column table and title it Angle Relationships. So our first angle relationship is adjacent angles. And adjacent angles are 2 angles. So 2 angles are adjacent when they have a common side and a common vertex, and they don't overlap. So what that looks like is we have 2 angles pushed up against each other. Here is their common side, and then they share a common vertex at the point. And so we think of adjacent as next to, but unless our angles are actually sharing this side and vertex, we wouldn't call them adjacent. So if they're just sitting next to each other, that doesn't mean adjacent. They have to actually share that common side and vertex. So then we have vertical angles, and vertical angles are angles that are opposite of, which means across from each other, when 2 lines intersect, and vertical angles are congruent. So we have 2 lines intersecting, which is how vertical angles are formed, and the angles that are across from each other are going to be congruent. So that would be top and bottom, side to side. You'll just look straight across, and we automatically know that that angle will be congruent. And this is going to be an angle relationship that reoccurs throughout the whole entire year. So will adjacent, but vertical especially. Like we're going to be trying to mark like everything we know in a diagram, all the measures we know, and then vertical angles is going to be coming up a lot. So then we have complementary angles. And now this is complement, which is not like giving some a compliment, which has an I after the L. Complementary means angles that add up to 90 degrees. And so we just have a diagram. Two angles. These are actually adjacent complementary angles. Now they don't have to be adjacent to be complementary. All they have to do is add up to 90, but these happen to be adjacent and complementary. So then we have supplementary. Supplementary are angles that add up to 180 degrees. And we have the two examples where adjacent is when they actually share a common side and vertex, and then not adjacent. So see, these still are right next to each other, but they're not sharing the common side and vertex, so they wouldn't be considered adjacent. And I just wanted to show you guys the difference because you know, this first diagram where they're adjacent is going to be another type of relationship that comes up in this table. But even though angles might not be adjacent in forming that line, they are still going to be supplementary if they add up to 180. So then we have a linear pair, and actually the example above is a linear pair. So a linear pair is angles that are adjacent and form a straight line, and linear pairs are supplementary. So they have to be adjacent and they form this straight angle, and so that's a linear pair. You could think about how the two angles form a line, and there's two of them, so linear pair. Then we have angles about a point, and here's our diagram. I know it looks kind of small there, but really I just want you to see that all three of these angles are meeting up at a common vertex. And angles about a point will add up to 360 degrees. You think of a full revolution all the way around is 360, and these angles are making up that whole 360. And then finally we have angles of a triangle. Angles of a triangle are supplementary. They add up to 180 degrees. And we have in a diagram here, let me see if I can make this a little bit bigger. There we go. So we have the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And then, you know, we have angle A, B, and C. They're color-coded, just showing that they add up to 180. So now when I said we're going to bring this up to par with our geometry standards, the question here is we're just given that the measure of angle 1 is 100 degrees, and we're going to find the measure of all other angles. Well, if you think back to our angle relationships that we just went over in the last table, here I see we have vertical angles, and we also have a linear pair, a couple different linear pairs. So those are going to be the two concepts we use to find all of the angles here. So we can already say that angle 3 is also 100 because angle 1 and angle 3 are congruent because they are vertical. So angle 3 must also equal 100. Then I have that angle 2 and angle 3 form a linear pair. I could have also said this with 3 and 4, but I used 2. So 2 and 3 are a linear pair and therefore supplementary. So the measure of angle 2 equals 180 minus 100. So I'm just finding out what's left over to get to 180, and that would be 80 degrees. So I know measure of angle 2 is 80 degrees. And then finally, the measure of angle 4 is also 80 degrees because angle 2 and angle 4 are vertical and they are congruent. And then our last example, now we're throwing some algebra in this. So this is going to be a reoccurring theme throughout geometry. We'll have a certain relationship, and then we will have some algebraic expressions that are thrown in the diagram, and then we need to use the relationship to set up an equation. So I want to think about, looking at this diagram, what type of angles do I have? And these are a linear pair. They're supplementary. So I know that this angle ABD and angle CBD add up to 180 degrees. So like I said, first thing you want to do is identify the relationship, and then second, set up your equation to reflect this relationship. So my equation is 4q minus 46, which I just got from this angle, ABD, plus 3q plus 6, which I got from CBD, and those add up to 180. I've literally connected them with an addition sign. And then we're just going back to some algebra that you guys did a lot last year. We'll be combining like terms, so I like to use an underline technique. I underline the terms that are alike, so I've underlined my 7q and my 3q once because those are like terms, and then I've underlined my constants, negative 46 and positive 6 twice because those go together. So when I combine my like terms, 7q plus 3q is 10q. And then negative 46 plus 6 is negative 40, and that still equals 180. I'm bringing that part down. So then finally, finishing off the equation, I would add 40 to both sides so I can get rid of this negative 40. Just trying to isolate q. When I add 40 to both sides, I get 10q equals 220. And then last, I divide by 10. And I get that q equals 22. So this is our last example. Make sure that you have taken complete notes and written everything down. There will be a quiz next class and it will come directly from the notes. So if you've listened and copied everything down, you should be able to ace it. See you in class.